This is Jupiter at Night, and it's filmed in front of a live internet audience. Good evening, everyone, and welcome to Jupiter at Night. My name is Chris, and joining me on the line tonight is Heather, also known as Mars Base in our chat room. Hey there, Mars. How's it going?
Hey, pretty good. How about you, Chris?
Good, and thanks for joining me again tonight for another episode about space. Now, one of the things that we've kicked around a lot on this show is long-term space stuff. I think it's probably been a reoccurring topic. And there was a news story that came out, 2 days ago, about NASA getting approval for funding on a 100-year Starship project?
Yeah.
And I thought maybe we should sort of talk about this and some long-distance space travel stuff.
Yep. Well, it's not as exciting as it sounds.
Honestly, I was pretty excited until you pulled a little cold water on me in the chat room.
Yeah,
so, all right, what's going on
water.
with this?
So it's NASA and DARPA. They've got money, but it's mainly to examine the business model needed to develop and mature the technology portfolio. None of the money is going to science. It's all about setting up the infrastructure on how, so that the infrastructure would be there to develop the science and to set up this kind of a long-term...
Because if you send a spaceship to Mars, you need you got to build the ship, and then you need a support infrastructure that can be available when the ships... Because once they're up in space, they're completely dependent on the people on the ground for a lot of stuff.
Yep. Yeah. You either have to do in-situ resource utilization, which is, using what you find out there, and some of the, you want to be able to call back to Earth and say, hey, how do we fit the square peg in the round hole? Can you guys help us?
Yeah, you got to have that team ready to do that.
Yep.
That's a good Apollo 13 reference there. Or Apollo 11,
yes.
Right? Apollo 11 reference.
13.
All right. So let's talk about this, though, because if we can get this 100 years project, and sure, it doesn't mean I'm going to get a Starship anytime soon, but at least it means not tomorrow, but they're thinking through it, and I like that.
Yeah.
I like that they're thinking through it. And once they think it all through, we're going to have a few different options on how we're going to travel, right? We're going to have different propulsion types we can pick from. So why don't we talk about some of those tonight? And the first one that kind of jumped out at me was the slingshot around the sun kind of thing, gravitational assisted drive. Star Trek fans might remember a reference where they go around the sun and then they time travel back in time. But it's not just suns. It can be launching around any kind of space body, right? Is that how it works?
Yes. Yeah. First, really quick, in case I mention it, specific impulse is just what scientists use to describe efficiency of
specific
rockets
impulse.
Or whatever. Specific impulse. It's change of momentum per propellant. So it's like how efficient are you?
Gotcha.
Is the specific?
I gotcha. So let's talk about
gravitational slingshots. Yep.
Gravitational slingshots. Yeah.
Shot around planets. I mean, the Voyagers did it. The problem is everything has to be just in the right spot. But if you aim towards a planet, the green line is your velocity. Your little red dot is your spacecraft, and it doesn't actually have to loop around it. It can just be altered by it. But you can see how much that gravity pulls it forward and increases its velocity.
So they just have to kind of skim it, and then they kind of...
Yeah, you just have to kind of borrow some of the gravitational momentum.
And it flings it in a sense.
Yeah, it just sort of flings it out, and then it can go a lot faster. It's how... So
that's kind of a cheater's move, isn't it? Because you can... because we were talking about on the pre-show, one of the problems with some of these engines is either their fuel requirements or their builds are so freaking heavy that it takes just a ton to get them up into space.
Yeah.
And if you can cheat a little bit and slingshot around, right?
Oh, yeah, it's totally helpful because the more fuel you need in space to go farther, the more you have to lift off the Earth, the more you have to load onto the rocket. It's this cyclical problem.
Exactly.
So if you can use that kind of technology where it doesn't require much fuel after you get off the Earth, then it's great. I mean, Voyager 1 is the farthest man-made object it's going to be. We've made stuff that we launched faster recently.
Right.
But because of the rare combination of planets and where all their orbits were, Voyager 1 was able to hit them all in such a way that it was able to just slingshot out there really fast.
Oh, so they hit the ideal launch time, didn't they?
Yeah. It was one of those that only occurs every, couple hundred years, couple thousand years.
Oh, ouch. So we're going to be waiting a while before we get something that great again. Now, if you're talking about we got to just get this thing off the Earth, we have to get it up into space. What jumped out at me is what seemed like an efficient design, maybe not for long distance travel, but at least for farting around the local solar system, is solar sails.
Yep. If you're not too concerned about how fast you get someplace, then sure, you can use the radiation pressure, solar winds, and super thin material to sort of catch that, and it's like sailing on the sea, essentially, just a little bit slower and using solar winds.
So the solar wind is actual radiation pressure? That's what solar wind is?
Well, you're using both. There's, it's throwing off actual material from the sun, and you can kind of use that, my very tiny material, you can use that to help blow the winds, blow the sail. But it's also just the radiation pressure from the sun will cause a little bit of that to give you some momentum.
Do we have anything using this?
Yes, in 2010, just last year, the Icarus is a spacecraft using the solar sail technology. It was launched. Oh. So we do actually have it out. We do have stuff out there.
And it's so is there going to be, do they hit a wall with how big of something they could move, or is that just not even an issue in space? The size, once you're up in space,
you're up, yeah. Well, I mean, so I mean, you can move something big. It might take a little bit longer because it still has mass.
Right. But they're ultra compact. I'm looking at a video you included in the show notes, and the thing can just like self-deploy once you get it up there, which is the great part. So that means it can be tiny when it launches and then just balloons out.
Yeah. Well, that was one of the big things. It's ultra-thin material. So it was figuring out how to get an ultra-thin material the size of a sail launched into space. Can you pack it up? Right. What kind of material can you scrunch into a tiny little box and then deploy without it tearing into a million pieces?
It looks like tin foil to me.
Yeah. That's essentially what it is. Really, really thin, expensive tin foil made out of more exotic materials. But
isn't that also a risk? Can't that just like rip? I mean...
Well, yeah, I mean,
like a meteorite or something? Just
if you have a microscopic meteorite come along, boom, you have a hole in your sail.
And what do you do then? I guess you'd have to have a system that could deploy a whole nother sail, wouldn't you?
You'd have to have a system that would deploy a whole other sail, self-repairing materials.
Ooh.
There's all sorts of different scientific advancements that you could do, but that's
self-repairing self-repairing sail would be amazing. Maybe like some sort of mesh or magnetic material or something that sort of just sort of reweaves together.
Well, there's the memory, the memory stuff. So if you poke a hole in it, as long as it's not actually torn off of it, could you make it remember, set a charge to it, and make it remember, this is how I used to be? And it wouldn't be perfect. There'd still be a tiny tear there, but at least it would be, for the most part, intact.
You know what seems like would be the perfect combination of technologies is solar sails and solar panels. Like if you could have the solar sail also be a solar panel so it's collecting power as it travels. Wouldn't that be neat? The materials probably don't match up yet, but...
No.
Down the road, it just could be your propulsion source and your energy source. That seems like that would be awesome.
Oh yeah.
Now this sucker here isn't going to get you out of the solar system though, and that's where you need a more powerful kind of engine, like maybe like
a really long time.
Like a fusion, like is that kind of where like something like a fusion rocket or something like that might come in?
Yeah, it has a really high specific impulse. It's really got a lot of bang for its buck.
There's that specific impulse again.
Yep, specific impulse.
What did that mean again?
It's efficiency. How much momentum can you get per unit of
acceleration or thrust or something? And so that's where the fusion...
per unit of propellant.
And that's where this guy kicks in. Because relatively for how much fuel you actually do have to ship it with, it can really move.
Oh, yeah, it can really put out a lot of momentum for that amount. It has less radiation than a fission rocket. Fission and fusion are a little bit different. And the fusion actually needs less shielding.
So probably less weight too.
Yeah.
Aha. And this is just burning hydrogen and some type of fuel, right?
Well,
it kind of depends on the engine
because it's using in a fusion reaction, you're taking two light atomic nuclei and fusing them together. And hydrogen is one of the lightest elements we know, so it's easy to take two very light elements, fuse them together, and in doing so, you release a huge amount of energy. And then you can use that to get momentum going and get your spaceship going.
I'm totally geeking out on the in the show notes. There's a link to the Wikipedia article on fusion rockets, and it is massively cool, but it's big. And
Yes.
only one visual? Come on, someone needs to go
Yeah.
hook Wikipedia up with more visuals than that. I mean, the
Well-
topic of this scope, of this
Well, it's not
magnitude.
something that we have, so it's all theoretical and
I see. That
artist
does count.
renditions and
Well, if we're going to talk about theory, I'd like to talk about traveling at the speed of light.
Sure.
I've become a bit of a Debbie Downer on this topic because I've started to suspect it's just never going to happen. And that, as a Star Trek fan, makes me cry on the
Makes you
inside. Yeah, it makes me
you
make
cry
me
on the
sad.
inside.
It does make me cry on the inside because the whole thing about Star Trek and Star Wars and all of those classic sci-fi dramas and epics is that you can go faster
than
than
light travel.
Yeah. So
Yep.
what's the holdup here? What's going on? With speed of light
holdup-
possible?
yeah,
I mean, I know it's crazy
goes back-
fast.
Yeah, well, it's 1,079 million kilometers an hour, 671 million miles per hour. I mean, it takes 8 minutes for light to get from the sun to the Earth, so it's chucking along. But the problem is, back at Einstein, the whole E equals mc squared.
Yeah.
Now, E equals mc squared is the simplified version. It's for a body at rest. When you add velocity in, then you get E equals y mc squared, where it's velocity. And as velocity approaches the speed of light, then the energy required to move an object approaches infinity. So the closer you get to the speed of light, the harder it is to move something.
Oh no.
And so that's where the problem comes in. It's this special relativity. So it's finding a way around that. So it's, can we bend space and time? Well, that's the other problem also, is depending on your point of view, whether you're viewing from inside the system or from in front or behind of an object moving, theoretically if you had an object moving at the speed of light, then it also warps space-time. So you can actually get this weird convergence of, depending on where you're looking from, if two objects traveling at the speed of light, one could be ahead. From one perspective, you could have A ahead of B. From another perspective, B is ahead of A. And from a third perspective, they're at the same point.
What?
So it's all of these things at once. It sort of gets into, is it time travel? It gets a little weird. So we're looking at, well, maybe we go at the speed of light? Is there physics we don't understand? Can we get around it? Can we make a bubble of space around us? That's
sort
fine?
of the Star Trek approach, right? Where you don't necessarily have to move the ship
you're
at that
not
speed. You just
necessarily
move the
moving
space
the ship.
around the ship. Yeah.
Right.
Yeah.
You're warping space around it so that it's sort of scooting you along, and you're kind of getting around that, or wormholes or anything like that exists.
And it looks like scientists think that's a practical, real approach to take to travel.
Yeah, well, I mean, there are theoretical elements that move faster than the speed of light. It's all theoretical, so it's just sort of hypothesis about how it goes.
Yeah, and I've heard also of experiments where they can like quantum entanglement, where they can move, they can alter the state of one thing and it instantly alters in another location and things like that. But that all seems super far out there. But if you're going to actually master space so that you can warp the area around a ship, I mean, the power required to do that is insane. And Star Trek's answer is antimatter.
Yes.
Are they crazy?
No, antimatter is real. It is a real thing. There are, anti-electrons are called positrons, just like electrons, but with a positive charge.
In fact, you've got an article in the show notes here that talks about the maturity of antimatter, and it actually makes me feel a little better. It says right here, their first thing is antimatter is real stuff, not just science fiction.
Yep. At the big CERN Hadron Collider over in Europe last year, they made an anti-hydrogen particle. It didn't last very long, but they did actually create
anti-hydrogen. Created it?
Yes.
Wow.
So it's real. We can't sustain it yet.
And if an anti-hydrogen particle were to come into contact with a hydrogen particle, they would explode? Theoretically? Is that the question? Is that the whole point of antimatter? Is that when something comes together with something else and then they touch, they basically blow up, and then if you can utilize that energy output, you can...
If they did that, then there'd be a huge amount of energy, and how could we contain it? How could we use it? How could you...
Oh, dilithium crystals. Yeah, you put you keep the antimatter in a magnet containment field, and then if you channel that through dilithium crystals,
of course,
money, you're fine. Yeah.
Do you know dilithium is a real element?
Now, really?
Yes, I have dilithium crystals in my lab.
Is it like been around for a long, long time?
It's just an element.
Oh, have you tried channeling antimatter through it?
I've tried heating it.
You did? You're such a nerd. I would too, though.
It was for a project.
Oh, okay. I thought you just like grabbed some and threw it in the microwave. That's what I was picturing. You're like,
microwave.
That's what I would do.
In a scientific oven.
Oh, okay.
Dish.
Well, see,
I'm not heating it up next to my lunch.
See, that's your approach. My approach would have been to throw it in the microwave. I would just see what had happened. But so what happens when you heat up dilithium? Does it do anything? Did it start smoking or anything like that?
Yeah, well, it can. Especially if you forget to put something underneath the ceramic when you're on a table.
Oh, did that happen?
Maybe. It didn't happen to me. It happened to a coworker.
Is there, before we sign off, is there any other closing thoughts you want to make or any notes in the show notes that you want to point out for people to go check? Because you included like electron drives in here or electrical propulsion.
A whole bunch of other stuff.
Yeah.
You know, the chemical reactions and all sorts of things that are happening now and in the future. One thing to note with antimatter is not anti-gravity.
Right. So you're saying I'm still going to have to float?
Yes.
But
unless
I can go
you spin
fast.
the spacecraft. You can always spin the spacecraft.
Yeah. Right? That's what they did. Yeah. There you go. I'll spin it. And if you got antimatter, you got power to spare, so you can spin the spacecraft, I'm sure. I like that. Well, Mars, thanks for coming on the show today and setting me straight with space travel. And you know what? Actually, I'll tell you this. You left me feeling a little more optimistic than I was before the show started.
Well, that's good.
After that 100-year space project and I found out they weren't actually building a ship, and then I read something that was saying, like, yeah, we're never going to go the speed of light. But you know what? After you think about it, I'm fine with that as long as we can warp the space around us. So
there you go.
Hey, I look forward to it. Maybe 1 year down the road, way down the road, I'll be like all gray and I'll have a cane next to me, but I'll be able to come on.
Year.
Yeah, no, years down the road, not 1 year. I mean years down the road. Yeah, that's one bad year.
That's a bad year.
It'll be something to the effect of, hello everyone and welcome to Jupiter at Night. And tonight we actually went into space. And then I'll finally get to talk about it and maybe I can Skype you up and you can come on the show and we'll talk about it.
There you go. Then we'll have holographic Skype.
Yeah, there you go. Beam you right into the studio. I like the way you think. Okay, everyone. Well, that wraps up this whole week of Jupiter at Night. Now, Jupiter at Night comes out every Tuesday, Wednesday, and Thursday. And, of course, we're live over jblive.tv at 8 p.m. Pacific. And you're welcome to join us and hang out in the chat room like Mars Base does. And then you know what? When people are cool, they just sort of hang out and chat in there, and you can make your way in, and then they even get on the shows and stuff like that. It's a really neat experience, and you only get to do it if you can join us live. And, of course, we know not everyone can, but we do all kinds of shows live, and you can find out all about those over at jupiterbroadcasting.com/calendar. There you have it. Well, thanks for joining me, Mars.
Thank you.
Thank you, everyone, for joining us this whole week, and we'll see you Tuesday night. Thanks, chat. We should give the chat room more love. Thanks, chat room.
Hi, chat.
They are kind of our co-stars down there, you know? I mean, look at them. They're down there rocking just like if they were in the show. And they've been here all week. They didn't even go away once.
Hey, I love my chat.